Now this is the next theorem. And AB is required. The circle is of radii 4 units. Okay. Now there are different versions for this. Now I want to know this angle, right? Now this is the theorem. Angle at the center is twice the angle at the circumference. Okay. Sometimes this theorem is also worded like this: angles created by the same chord at the center equals twice the angle created by the chord at the circumference. Now you can replace the word chord with arc, right? So in this case, we are given a completed triangle. We are expected to find the value of AB. We need this angle. Now if this angle is theta, this angle will be 2 theta. That is the output for this theorem, right? So having mentioned you this, let me complete this question. So we are expected to find the length of AB. Now this is going to be 4 units, this is 4 units. We need 2 theta. Now if this theta is given to be as 30 degrees, we would directly be able to get 2 theta. So this angle will be given in questions like these. So that would mean if I were to draw this requirement, this is A, B and O, this angle is going to be 60 degrees. This is 4 units, we need to get this. So I will use the cosine rule. By cosine rule, this distance AB squared is equal to OA squared plus OB squared negative 2 times OA OB times cosine of the angle between them, 60 degrees. So AB squared is equal to 4 squared plus 4 squared negative 2 times 4 into 4. Cos of 60 is 1 over 2. So 2 gets cancelled. 16 plus 16 negative 4 4s are 16. They get cancelled. Right, you have a 16 and a 16 and a 16. You have 116. So AB squared is equal to root of 16, or I would say AB is equal to root of 16. So AB is equal to 4 units. You say is that we are dealing with the equilateral triangle. So triangle OAB is equilateral. Right. So that is all about it. But the important concepts that we have to learn here is the angle created at the center is twice the angle created at the circumference. So that's the end of